Today, we are learning lesson 5.5 about inequalities in a single triangle. First challenge is to draw an obtuse triangle of two scalene. So you can clearly tell there are three different side lengths. And then what do you notice about the longest side and the largest angle, right? Mark them. Same thing with the shortest and the smallest. What do you notice? Right, so I'm making an obtuse one. We'll make it pretty clear. We'll make this side short, this one long. Right? And then if we connect kind of our ends, there we go. Right, with our largest angle. Clearly I meant that angle to be the largest. What sides are largest? This side's our largest. Supposed to be an A, not a 9 looking. Right? What about the smallest? This angle definitely looks small. We'll call that one C. And this side's the smallest. So what do you notice, right? The largest angle is opposite the largest side, or longest side. Smallest angle is opposite the smallest side, and vice versa, right? So, if one side of a triangle is longer than another, the angle opposite of that longer side is larger than the angle of the opposite, the shorter, right? So 8 bigger than 5, so going opposite, angle C must be greater than angle A. Okay? That also works with angles, right? Same thing here, 50 is bigger than 30. So BC must be bigger than AB. Okay? And that is what we're going to start with today. Listing the sides from longest to shortest, but then give us any side information. They gave us angle information, right? So, two ways to do this. You can either just look at the picture and clearly tell, right? 121 is the largest, so RT is the longest. Then what's next? 30 is bigger than 29, so RS is the next longest. And then what side haven't I picked? ST. Where some might need the 121 bigger than 30, bigger than 29, and then you go your opposite, right? Or if we name it with one letter, angle S, angle T, angle R, and you'll recognize that the side opposite doesn't have the letter, right? Angle R's opposite side is ST. Angle T's opposite is RS. Angle S opposite is RT. So, just a little note there, so that's another way of doing that. Moving on next, which angle is the largest? 68. Opposite of 68 is AB. So AB is my longest side, greater than. 58 is next. So AC is my second longest, and what's left over, haven't mentioned BC yet. You can maybe mark them first, second, third, right? Whatever, however you want to do it. Now that was angles to sides. What about sides to angles? Same idea. Okay. 18 is largest, it's opposite angle S. 17 is bigger than 15, so that one's angle T. Smallest one's going to be angle R. And again, just a note, right? TR, letter that was missing, S, of the triangle STR. SR, letter that was missing, T. And then R, the missing letter was R of ST, right? So just a little note on how those opposites work, if that's a struggle for you. Moving on, 31 is the largest, right? 31 bigger than 27, bigger than 24. So angle C bigger than angle B, bigger than angle A. Next. 3 inequalities. 2 of them don't matter. Interesting. What does it say? Right? The sum of the lengths of any 2 sides of a triangle is greater than the third side. So let's pick a common right triangle, 5, 12, 13. Okay. Let me quick piece it together here quick with the same letters. And we'll call this ABC. Okay. Which inequality is going to give me the most information? And it's not necessarily letter related, right? This one says 5 plus 12. Is that bigger than 13? Yep, 17 is bigger than 13. How about over here to the next one? So we'll do the next one down here. AC, which is 13, plus BC, which is 12. Is 13 plus 12 greater than 5? 13 greater than 5. Of course that's true. Last one, we've got AC plus AB, so 5 plus 13. Is that greater than 12? Of course that's true. 13 is bigger than 12. So how can we break this down into literally one step, right? This was the one that was the important one. And it was because the two smallest needed to be greater than the largest. So rephrasing this whole theorem, two smallest sides sum, right, because you're adding them together, must be greater than the third largest side. And that's literally what this breaks down to. Then we're just looking at one inequality, potentially, if you give me numbers, right? They give you three numbers, two smallest ones, add together, is it bigger than the third one? Okay, the largest. Triangle has one side length of 8 and another side length is 21. What are the possible lengths of the third side? So think about the two different sides that third side could be. There's two situations you need to think about. Either our third side is a smaller one, or it's the largest. And by smaller, I mean it's one of the two smaller. It doesn't mean it's the smallest. That's why I use smaller. Right? So either it's small or it's a large. Right? Let's pretend it's small. If it's one of the small ones, we would say 8 plus x needs to be greater than the third side, which is 21. Solving this, x is greater than 21 minus 8. X needs to be larger than 13. Next one, now we're going to pretend like x is the largest side, right? So that means 8 and 21 are smaller than it, so 8 plus 21 must add to be larger than x. And we get, not really much work with this side. 29 is larger than x. Now we can connect these two together. X needs to be bigger than 13 and smaller than 29, meaning 13 is less than x less than 29. And there's our answer. Now you could kind of turn this into a formula. So think about it. Where did 13 come from? Where did 29 come from? 13 was our largest side given to us minus the smallest. So largest minus smallest, x has to be bigger than that. 29 came from largest plus smallest. We did it in the opposite order, just to keep it the same. So here's kind of the formula we're looking at. Large minus small is less than x, which is less than large plus small. Those are your two options. Sometimes we can do that right away. Other times in some of the examples coming up, we have to kind of settle them one case at a time. Next one, triangle has a side of length 15 and another of 18. Find the possible length. Using the formula I just showed you, go ahead, give it a go on your own. Using the formula, this is what it looks like. Again, 18 is a large number, 15 is a small. Large minus small gives us 3, less than x, less than 18 plus 15, because again, we're adding them. So 3 is less than x, and x needs to be less than 33. Otherwise, it would be too long and it'd be a straight line. Moving on. Given angle A is less than angle B is less than angle C, describe the possible values of x. So let's write underneath what side's opposite. BC is going to be less than, AC is going to be less than AB. Now again, this is where that three-letter trick helps you out. This is triangle ABC. So what's not A, BC? What's not B, AC? AC. What doesn't have C, AB? And now that I have that, we can plug in what we have, right? So BC is 10, so 10 less than AC, x plus 2, is less than, what's left, 18. So 10 is less than x plus 2, less than 18. I need to solve for x, so I need to subtract 2. However, because this is a chain inequality, we have to subtract from all three sides. We can't just subtract from 2 of them, we have to do all three. So I get 8 less than x less than 16. So x has to be between 8 and 16 for this top part to work, right? If it was less than 8, it wouldn't be bigger than 10, okay? If it was more than 16, it wouldn't be the middle side, it would be the largest side, okay? So, moving on. Angle A less than B less than C, describe possible values again. BC less than AC less than AB. Plug in. Now notice this time we have more than one x. So we'll put the chain inequality together, but you'll recognize that there'll be something that won't work. So plugging it in, 8 minus x is our smallest side, AC is 3x, and AB is 15. Okay. If I wanted to solve, I need to get x's in the same spot. But if I add x to all three sides, look what happens. 8 less than 4x less than 15 plus x. We can't get rid of it. It keeps shifting the x to the right or to the left. So what you have to do is we only need this part to be true for one side, right? 8 minus x needs to be smaller than 3x. And we're going to solve this part. Plus x to both sides. 8 is less than 4x. Divided by 4. 2 is smaller than x. So x needs to be bigger than 2. And then we're going to deal with the other side over here. 3x still needs to be less than 15. Divide by 3, divide by 3. So x needs to be less than 5. And now we can chain these two together so that 2 is less than x is less than 5 is our final answer. And again, it can't be bigger than 5 because then it would be larger than 15. Or 15 or larger, right? Moving on. Same inequality, A less than B less than C. Possible values of x. Again, BC smaller than AC, smaller than AB. We have x's in each equation, so we're definitely going to need to do piece at a time. So BC is 2x plus 3 needs to be less than AC, which is 6x. Okay, minus 2x from both sides. 3 needs to be smaller than 4x, so divide by 4. 3/4 is smaller than x, so x needs to be bigger than 3/4. Okay. Now, doing the second part, we have 6x less than AB. Now we're bringing 5x plus 8 into the picture. Right, and subtract 5x from both sides. And we get x needs to be less than 8. So now we have x is bigger than 3/4, x less than 8. Put them together to get 3/4 less than x less than 8. Moving to the next one. The last set, we've got A less than B less than C. Now, as a note, why is this important? I used to have problems in this lesson where that was, maybe only one of them was in there. And then you had to technically check to find what your answers were really, because without an angle being bigger than another, you kind of have to figure out which inequalities work, right? Because 4x plus 8 technically could be bigger than 7x plus 2. Could be, doesn't have to be, right? Depending on what x is. So, plugging it in, BC less than AC less than AB, and now we're kind of splitting it into 2 because they all have x's in it. So BC less than AB, we get 3x minus 1 less than AC is 4x plus 8. Solve for x, so minus 3x minus 8. We get negative 9 is less than x. Well, x needs to be bigger than a negative number. This can't be a negative side. That can't be a negative side. That can't be a negative side. So that doesn't really help us a lot. X is technically more limited to that because all our sides need to be positive. But we're not dealing with that right now. Next, AC less than AB becomes 4x plus 8 needs to be less than 7x plus 2. Solving for x, minus 4x from both sides, minus 2. I get 6 less than 3x. So we got 2 is less than x. Now recognize both of these are less than. Okay, which one makes sense? Right? Are they both our answer? Can we just kind of sandwich them together like this? Right? Does that make sense? Doesn't make sense. Can't be bigger than, right? So we'll get a number line just for 1 second here. Right? As a reminder, here's how this number line would graph. X is greater than -9 would be like that. All numbers above 9. X greater than 2 says this. All numbers greater than 2. So to do both, you're just going to actually listen to the second one. Right? This one here eliminates the number, let's say, 0. Right? 0 is not bigger than 2. But 0 is bigger than -9. Right? So you have to do the one that's true for both, which basically means this one takes over and wins. So x has to be greater than 2, reading it this way, is our final answer, or you could still write 2 less than x. So literally that's all it is. Okay? Because 7x plus 2 is always going to be larger than 4x plus 8 for numbers bigger than 2. And that wraps up this lesson. Feel free to let me know if you have any questions.